Hi, welcome to part 2 of this series. In this video, we are going to add a mutation to create a user. The link to the repo is in the description. If you want to follow along, just check out the tag part 1 or part 2 for the complete code. Then create a branch over that commit and you are good to go. Cool. Let's open Visual Studio Code. And the first thing that I want to do is to fix this snake case an API version. Juniper will automatically convert to camel case for you, so this is not needed. Now, we are using an empty mutation, but that's only for read-only APIs. We also want to use this API to create and modify objects. So, as we did with the query, we also need to create a new mutation struct. We will leave this empty, and then we can implement the methods. So, same as the query, use the macro Juniper GraphQL object and specify the context type. Then, we can create an asynchronous function to create the user. This method will receive the context as a reference and also an input. This input will have whatever attributes we need to create the user. So we can create a new struct createUser to represent that. Then, this will return a result on success. It will be the user we created and otherwise a field error. Great. Now let's go to the users module and create this createUser struct. So public struct createUser. Now let's copy the attributes we need: username, email, password, bio, and image. Get rid of the skip macro as we do need to handle the password. And finally, we need to derive the GraphQL code for this. But instead of GraphQL object, we need the GraphQL input object. So let's import that. Now go back to the GraphQL handler module and import that createUser. Now we need to do something similar to get the user's methods. So we can copy the client and prepare statement code. As you can see here, I added a couple of error logs using slug scope. So this will log the error and then return it. So let's copy that and let's update the log context. It is the query from the createUser method. Okay, so for the query, instead of the select, we need to insert into users the fields username, email, password, bio, and image. Then, as values, we need 5 parameters. After this, we need to return the created object. So, returning, and to return every field, we use a star. Great! Let's create the variable for the created user. And using the client, we call the query. Pass the reference to the prepare statement and the reference to the list of parameters. We get the parameters from the input object, so the reference to the input.username, input email, and for the password, we cannot just store it like that in the database. We need to store a hash. I'm going to use Argon2, that is said to be the successor of Bcrypt, but you can use the hashing function you like the most. For Argon2, I found this interesting crate called Argonautica. It has an extensive documentation and the same features as the C version, so it is fully customizable. The downside right now is that it depends on the C version and you need a C compiler to build it, so I need to install it in my machine. After that, we just add the dependency in the cargo.toml file. I will also include the CMD feature. CMD is just a technique for data level parallelism. Good. Now, to try this quickly, let's go to the users module and implement a method for the createUser struct, a public function password hash that will return a string. I also need the reference to self to get the plaintext password. Now, let's import from Argonautica the hasher struct. Then create an instance with the default configuration with password, and here we pass the password that we want to hash. Then we also need to have a secret key, my secret key, to change in prod. This secret key should be a configuration, but we can deal with that later. Now we can run the hash function. There is a blocking and non-blocking version that we can use. The non-blocking version is currently using an old version of the futures library, but luckily there is a compatibility feature that we can include. So let's go to the cargo.toml file, and in the futures package I will add the compat feature. Now back to the users model module, we need to include the compatibility trait, so we use futures compat future o1 compat extension, and then we can call .compat after hash non-blocking. Let's also make this function async and then use .await. Now this will return a result, either the string or an error. So for now, let's just call unwrap and deal with the error later. Let's go back to the GraphQL handler module, and now I can call password hash directly. Then I need to add input bio and input image, and now we are done with the query params. After executing the query, I want an iterator over the results, and I need to convert them to the user struct, then collect the results, and I should get either a vector of users or an error. If I get an error, I can just return it right away with the question mark operator. In this case, I created a single user, so I only expect to have a single value as a result. So let's call pop to get that value from the vector, and I can then return the created user wrap in OK. It looks like I forgot to call await after query, so let's add that with the question mark operator. And pop returns an optional value, so let's just call unwrap for now and deal with the error later. Let's also import the create user struct. Then the password hash is an asynchronous function, so I cannot just call it like that. Let's move it into a variable password hash and assign input.passwordhash.await. And one last thing, back to the password hash function, it is expecting a reference to the password, so let's add that, and now we are ready to test. Let's run cargo check. It looks okay. Now cargo run. Go to the browser and open the graphical IDE. If we look at the documentation explorer, we can only see the root query. That's because we are still using the empty mutation. So let's go back to the GraphQL handler module and replace the empty mutation with our mutation struct. Good. Now let's restart the server, and now we can see the mutation in the documentation explorer. Let's take a look. We have the create user field available with an input argument of type create user. Right now, I only have a single user entry in the database. Let's look at the definition of the create user, and here are the fields we need. So let's do a mutation query. I will give it the name create user, and inside it we call the field create user with an input argument. And I could write the input inline right here, but let's have it as a variable. So I will define the input variable here with the type create user. Then I can pass that variable to the field argument. Once the user is created, I need to define here which fields of the user I want the server to return. So I will just ask for all the fields. Now to define the actual value of the input variable, I need to use this query variable section. And here as a JSON, I can define the input variable with the username user2, the email user2@example.com, password some pass. Just run the query, and we can see the user2 was created with an ID and timestamp values. Let's take a look at what was stored in the database. Select star from users where username is equal to user2, and we can see the UID, and as a password this huge hash with some metadata of the algorithm at the beginning, the argon2 variant used, the memory, iterations, parallelism, and we can also see that the value and image are empty and that we have timestamp fields. Cool. We should be able to also specify the value and image if we want. But if we run the query again like that, we get an ugly error. A duplicate key value violates the unique constraint for user's username key. It will be the same for the email address. We need to improve the error handling here with a nicer user-facing error. So let's go back and import from the errors module the app error struct. The idea is to use this instead of the field error. But before we can do that, we need to have a way to convert this struct into a field error. So let's go to the errors module and we need to import from Juniper the into field error trait and the field error and value structs. Then we can implement into field error from app error. This trait has a function into field error that will do that conversion. We can remove this generic type here and create a new instance of field error with the actual message that will be the result of the message method from app error. And the extension is just an extra metadata for the field error. We don't need any right now, so let's use the value null here. Good. And let's look at the error types. So far we have the database error and not found error. We could have another one for an invalid user input or an invalid field, and we won't use this error as we would with a REST API, so there are a couple things here we can just delete. There is no need to convert the error to a status code yet, so I will just delete that for now. I will also delete the test case for it and some unused imports. Finally, we can have a default message for the invalid field error. So let's copy this case for invalid field and the message will be invalid field value provided. Good. Now back to the handler. The unique error occurs right after the query. So let's do a map error and the error we get in the closure should be a database error. So let's import that. It comes from the Tokyo Postgres library error and that's the error we want. I will also import SQL state. We need a way to know when we get a unique constraint error. Luckily, a database error often have a error code. That is an optional value, so we can map that, and in case we do receive the code, we can compare it to the unique violation error code. Now, let's do a match on that result. And if we do receive true, we return an app error. The cause is the original error and the message will be username or email address already exists. That should also be a way to get the action column that caused the error so we can be more specific. And actually, there are many ways to handle this. We can do a second query to find which one is already in the database. Or we could ask for the email first and then as a separate update create the username. But anyway, let's keep this simple. So the error type will be invalid field. On any other case, we will convert the original error into an app error using the from error method. Now let's replace this unwrap after pop. If we didn't get a database error but still we don't get the created user, we don't know the cause of the error, so let's return an app error with the message unable to create the user, and since we don't have the cause, it will be none, and the error type will be DB error. And finally, the question mark operator, so we get the user. Now let's build the app again, run the same query, and now we get the user facing message. Cool. What else can we do? We can move the hardcode secret key to a configuration. So let's go to the configuration module, and this is the idea. There are many ways to handle this, but we can have a hashing service. So we'll create a public struct hashing service. I will derive clone for this struct, and this will hold the secret key as a string. Then we can implement methods for the hashing service. The first one is a public async function hash. We can also have the function to verify the hash later. Hash will receive a reference to itself and the password we want to hash, and will return a result with either the password hash or an app error. So let's import app error. Now we can do the same thing. Create the hasher instance with the default configuration, specify the password and the reference to the password parameter with the secret key and a reference to self.secretKey, hash non-blocking, compat and await. Be sure to also import the compatibility module. Finally, we need to convert the hashing error to an app error. There is plenty of room for improvement here. For instance, we can check the maximum and minimum length of the password, check that it only includes certain characters, numbers, and symbols, and that it should be UTF-8 and so on. But for now, let's map the error and return an app error. The message will be some invalid password provided. The cause is the original error and the error type is invalid field. Now this secret key should come from the server configuration. So let's add another field to server config, a public secret key of type string. Then we can create the hashing service instance directly from config. Let's create a public function hash service. It will receive a reference to itself and return the hashing service. Then I can create an instance of the hashing service with a copy of the secret key. Then I need to update my .env files to include that environment variables, server secret key, and my secret key to change in prod. Cool. Now let's go to the main file. This is not related to the series, but I added the course configuration here as a middleware. It has the allowed origin as a server URL, the allowed methods, get options and post, the allowed headers, and support for credentials that we will add in the future. Anyway, let's create a variable for the hashing service after creating the connection pool. We can get it from config.hashingService. Then we add that hashing service as an application data so we can have access to it from the handlers. Now let's go to the GraphQL handler module and let's add another attribute, hashing, in the context. It will be an arg for the hashing service. So let's import that. Then let's go to the password hash code again and remove the password hash function from the users module. We'll replace it with context.hashing, then call the hash function and pass input.password as parameter. And since this hash function returns a result, let's use the question mark operator at the end. Cool. Now one more thing, let's go to the handlers module and we need to get the hashing service from the application data as we do with the connection pool. Now let's create a hashing variable and get the arg value from hashing service into inner. We add that to the context and we are done. Now let's build and run the server again. We will deal with the unused imports later. Now let's try a couple of queries to make sure everything works as before. I got the same error, cool. Let's create a third user and add an image to run the query and it worked. Great! And that will be all for this video. If I made a mistake or if there is a better way of doing this, let me know in the comments. If you liked the video, hit the like button and subscribe for future videos. It will encourage me to make more and better content. Thanks for watching and stay tuned for the part 3.